So, hello guys, and welcome back once again. So, today we are back with another really good question from the Maths Explorers paid test series. So, guys, this question is a really good question on probability, like PNC obviously, and probability mixture. So, without any further ado, guys, if you want, you may try this question once for yourself. I will wait for a few seconds and then I will start off solving this. Okay, so guys, I hope now we can start off solving. So first thing is, before going into the options, we have to read the question. So first is Mr. A randomly picks three distinct numbers from 1, 2, 3 up till 9 and arranges them in the descending order to form a three-digit number. Okay, so if we see for your Mr. A is, I guess, picking up three distinct numbers from 1 to 9. So basically, Mr. A will have 9C3, which is, I guess, come out to be equal to 84. Just calculate. This will come out to be equal to 84. Okay. So this is nothing but your N of A. And in case of Mr. B, who picks up three numbers from 1 to 8, it will be 8C3, which is, I guess, equal to 56 or NB. So basically this is NA and NB, and now if you want the total, we want the total sample space, right? It's like if you have done those problems on dice where in the beginning, like very in the introduction of probability in class 11th, when you do your dice sums, you have seen how they write down the complex, I'm sorry, not the complex, sample space in grids. So basically you can consider this as a grid with A as the rows, B as the columns, or vice versa. Whatever, you can choose anyone as the row and the other one will be the column. So basically to find out the sample space, NS will be nothing but your NA into NB, which is 84 into 56. So I don't know basically whether we will actually get something fractions that will cancel this out or not. Anyways, I have calculated it. It will come out to be 4704. Okay. This is the size of your sample space. So now if we move on to the options one by one. So basically the first option, option number A, I will just take this a little bit up. Okay, so option number A says probability that Mr. A's number is always greater than Mr. B's. That is, Mr. A will pick one number. So it is being said that the probability that the number that Mr. A picks is always greater than Mr. B. The probability that this thing happens is 1/3, 1 by 3. So let's test whether this will be correct or not. Okay. So guys, as per the condition of the question, we have to find out the probability that Mr. A's number is greater. Now we are talking about a three-digit number here, right? The three digits being selected by capital A, Mr. Capital A, such that the number is greater. So guys, one thing that should automatically come to your mind is if the number has to be greater, then one permanent solution for this number to be greater always, no matter what. Permanent solution, okay, that would be to assign the first digit as 9, because Mr. B can't choose 9. Mr. B can choose any digit from 1 to 8. So whatever, like, what is the maximum number that Mr. B can choose? It is 888. That is the maximum number, I guess, that Mr. B can choose. So in that particular case, like, Mr. A's number will always be greater if capital 9 is there here, right? So basically what we need to do is we need to find out all sets, three-digit sets or sets of three numbers which include 9. So 9 will obviously be one occupied, and now the rest two unoccupied positions in the set we have to select amongst the A numbers 1 to 8, because those numbers are included in A as well as B. So that can be done in 8C2. And if you calculate 8C2, I guess this will be 8 factorial by 6 factorial, 2 factorial. So 8 into 7 by 2. 56 by 2, this will come out to be 28. So probability of A always being greater than B, you can write always also if you want, AL. This will come out to be equal to Sample space being your okay guys, wait, there's a twist here. Basically, what mistake that all of you will do is that I was also going to do, that you will put 4704 or 84 into 56, but don't do that, because it is given probability that Mr. A's number is greater than Mr. B's number. So basically here you have to include the sample space only of Mr. A, not of Mr. B. Okay, you have to include only the sample space of Mr. A because we are putting Mr. A as condition here. This is not exactly conditional probability. Not, don't mix this up with conditional probability. Okay, that is like, it looks very near about both the concepts, but it is not exactly conditional probability. But this denominator here will be 84. Okay, we will follow this in the next options also, so you should understand this. So this is 84 guys, and above we will have 28. So if you calculate this, this will come out to be 1 by 3, which means option number A was actually correct. Okay. Okay, so guys, moving on to the next option, which is your option number B. Now, option number B says, I'm reading it for you, don't worry. Option number B says probability that Mr. A's number is same as Mr. B's number is 1 by 84. Okay. Okay, guys, like I actually found out a better idea to explain to you why we took 84 only as the sample space in the first option. Okay, listen to me carefully. I am going to read out something. Listen to me carefully. Our first option statement was probability that Mr. A's number is always greater than Mr. B's number is 1 by 3. Now, don't read this like that. Try to interpret this in what I am saying right now. Interpret this as Mr. A's number is so large that no matter what Mr. B picks, A will always win. I am reading it again. Mr. A's number is so large that no matter what Mr. B picks, A will always win. Okay, and like this is the statement on which whose probability we are calculating. Now if you read this statement once again, Mr. A's number is so large that no matter what Mr. B picks, A will always win. This thing basically means that Mr. B here has no dependence at all. Mr. B's sample space here will have no dependence at all. We are calculating the first option's probability exactly independent of Mr. B only for Mr. A. Okay. Now, when you go into the later options, like when you go into your option number B, C, D, you will understand that we are taking the sample space as 84 into 56 because there the probability will depend on both A and B. But in the option number A, this was being calculated only for or only with respect to Mr. A. Mr. B didn't have any role here. Okay, that's why we didn't take 56. If you guys are still confused, just go back a few seconds and listen to that line once again very carefully what I said. Okay, listen to that on loop maybe. If you still don't understand, listen to that 5-6 times on loop, you will understand because I framed this line just right now and it is very beautifully framed. Okay, it is actually speaking out to you why these two factors are different and why we didn't take the sample space here in the denominator. Okay, I hope guys this was clear. So moving on to option number B guys, where they are saying that Mr. A's number has to be same as Mr. B's number. So for that thing to happen, like A is picking numbers from your 1 to 9 and Mr. B is picking numbers from 1 to 8. So if they have to pick up the same number, first thing is you have to exclude all cases where A is picking up 9. Okay, so excluding that means we don't have to like calculate like complementary method or something. We don't have to do that. We will clean it. What we will do is we will make a Mr. A select only those numbers which are between 1 to 8 and we will not take 9 only. That's all. So A and B selecting in between 1 to 8 is the only possible case where they can actually select equal numbers. So probability of that, like the number of cases where that happens, first thing is 8C3 because there are 8 numbers, so 8 exact same numbers, amongst that you select any 3. So 8C3, and if you calculate this will come out to 56. We already calculated. So guys, P, or probability that number of A is equal to number of B, will be equal to 56 whole divided by, this time we take 84 into 56. Why? Because both A and B are participating in this case. So basically this will come out to be 1 by 84. Okay, and I guess option number B is also then correct. Okay, so moving on to your option number C, where option number C says probability that Mr. A's number is greater than Mr. B's number is 37 by 56. Okay, so basically I brought you back to the screen because there is a huge twist. This question is a perfect representation of the fact that if you don't read your questions properly, you will make mistakes which will make you cry like anything. Okay, you will later on cry like what I did, what did I do? Okay, you will give yourself like a whole lot of words, you will say to yourself, why did I do this? If you read option number A says probability that Mr. A's number is always greater than Mr. B's number. I am highlighting this. Wait. What color should I take? Red color. Mr. A's number is always greater than Mr. B's number. In option number C, Mr. A's number is greater than Mr. B's number. There is a huge difference between these two. And what is the difference? Basically, here in option number A, probability that Mr. A's number is always greater. Okay. If you want to treat this as conditional probability, if you are very adverse on the fact that, oh, no, I just want to treat this as conditional probability, I don't understand anything else, then you can. Because in option number A, they are telling probability that Mr. A's number is always greater. They are telling you that Mr. A's number is always greater. Okay, which they are not telling you in option number C. They are telling you that Mr. A's number will always be greater than Mr. B's number in option number A. And in option number C, they are telling you Mr. A's number is greater than. There is a difference between the two. That's why like always greater permitted you to take 9 permanently in the first place. But when it is greater than, you can't. Because if it has to be always greater, you can take 9. But if it is not always greater, it is only greater, then beyond 9, there will be cases where 8 arrives, 7 arrives, all those cases. Okay. If I tell you a very analytic sort of definition of this thing, then you can write it like this: always greater. This thing would mean that the first place in the 3-digit number, the first place is reserved for 9 always, no matter what. No matter what, the first place is reserved for 9 only. Only greater. This means that the first place will not only be reserved for 9, it will be reserved for 8, 7, 6, 5 and whatnot. Whatever numbers are there, okay. Basically, always greater treats only those cases where 9 is the first digit. That is why you calculated this 1 by 3 so easily and so efficiently. But option number C is telling you, it is screaming and telling you, take all the other values also, not only 9. So that's where your difficulty arrives. Okay, I hope now it is clear. Like this one word always, like it can twist your entire question. Okay, this can be the barrier between your +4 and -1, this one word always. Because people, they will tend to make a mistake. They will take A and C, either like there's only two ways possible: either they will take A and C in the way it is supposed to, or they will take A and C in the exact opposite way, which is not supposed to. They will calculate they will calculate option number C in option number A and option number A in option number C, and that's why their marks is gone, although they have calculated it really perfectly. Okay, that's why your one word, even a one word in the question can twist the entire question, so be careful. Anyways guys, so let's move on. Probability that Mr. A's number is greater than Mr. B's number is given to be 37 by 56. So I guess we can take a number of cases here. Okay, so guys, the case number 1 is when A1 is greater than B1. See, there can be two possible cases. Either A1, now what is A1, B1 you might ask. A1, A2, A3 are the numbers here which are being selected by Mr. Capital A, and B1, B2 and B3 are the numbers which are being selected by Mr. Capital B. And as the numbering is done in the same perfect order, they are being selected. Please note. So A1 being greater than B1 is one case, and another case that we are going to explore, the next one, is A1 is equal to B1 is equal to some value. These are the two only possible cases for which Mr. A's number is greater than Mr. B's number. Okay. So if we let A1 to be say some I, because what will happen is we have to sum this up. Okay, I am getting a general formula, and after that, when we get the general formula, we will have to sum this up. Only after that we will get the total value of the numerator, total value of the number of cases. So basically, if A1 say is equal to I, number of A subsets with largest I. Now what that can be? So it will be nothing but your I minus 1 C2. Now listen carefully why. Basically, my target in this is to ensure that the number Mr. A is choosing is greater than the number Mr. B is choosing. So if I have to make sure that Mr. A's number is greater, then I will always, when I try to form this 3-digit number, or rather when I try to pick up A1, I will always try to pick up A1 to be as large as possible. As large as possible. It can be 9, 8, 7, whatever, but I will try to pick it up as large as possible. That's why I am telling, if we pick it up, say, if I pick up 9 only, because 9 was a singular case in that option number A, but here it is not the only case. There are other cases. So if I pick up 9, after that I will pick up all those numbers which are before 9. If I pick up the ith number, then after that the rest of the numbers A2 and A3 that I choose will be ranging in between 1 to I minus 1. That is the reason why we took I minus 1 C2. Okay. They will be ranging in between 1 to I minus 1. That is why we took I minus 1 C2. So this is the number of A subsets, and number of B subsets will be and Y2, because one number is already selected, the largest one. We have fixed that to be equal to I. So it is selected. And I minus 1 is before that for the other two numbers. So this selection is only in case of A, not in case of B. So number of B subsets with your, I guess, largest, I will write this as less than I. Why less than I? Because what will happen is, if this is 1 to I minus 1, to make sure that the number B is less than the number A is selecting, the the assurance that the number B is selecting is less than the number A is selecting, to make sure we will always select all the 3 digits of B, like we will make Mr. B select all the 3 digits in between 1 to I minus 1 again itself. Okay, in between 1 to I minus 1, B will select the 3 digits. A has selected 1 digit as I, and the other 2 numbers or 2 digits he is selecting in between 1 to I minus 1. But in case of B, he will select all the digits in between 1 to I minus 1 itself. So this will also actually, not same, it will come out to be I minus 1 C3. So basically, if we find out the total contribution, it will be nothing but your I minus 1 C2 into I minus 1 C3. Okay. So this is for I, but we need all the values. So basically what will happen is this will be summed up I minus 1 C2 to I minus 1 C3. Okay, so this will be summed up in between. I hope you can understand, because it's I minus 1, right? So this can't be 2, it can be. It can be 2C2. Obviously it can't be 2C3 again. Right, it can't be 2C3. So this summation will be from I equals 4 to 9. Why not 3? Because that will be 0 obviously. So it will be from 4 to 9 considering I minus 1 C3. Because that will actually create the boundary case. So I equals 4 to 9. Okay. So guys, this will be bit of calculation. Please do it. This will come out to be, I will tell you the values, 3 plus 24 plus 100 plus 300 plus 735 plus of your 1568. So this will totaling up come out to be 2730. Okay, I have calculated this. I didn't go into complexity with binomial, or if we can calculate with binomial or something else. If you want, you may try out and see if we can do that. I have not explored it. If you do explore it and find something else, then surely inform me. So this is your 2730. Okay, so that is the case number 1. In case number 2, okay, so here in this case, A1 is equal to B1 is equal to I. This is the case I told you before. So basically why? Because we are fixing both A1 and B1 here as equal to I. So if we are fixing both, then actually there are basically 2-digit pairs remaining, A2, A3 and B2, B3. So whatever comparison, selection, whatever will be done on the basis of comparison of these two pairs. So all of them will have values drawn from, you can understand, because already I has been assigned, right? So all of them will have values drawn from 1 to I minus 1. So if that is the case, then for each pair or each tail, you can say, you can call these pairs as tails, 2-digit tails, because it is like the tail of the number, right? So anyways, you can call it pairs or tails. Like for each pair, there will be I minus 1 C2 choices. First thing. Listen carefully. This is I minus 1 C2 choices for each pair. Now, if you study the ordered pairs of A2, A3 and B2, B3 properly, you will find out like it's not basically something worth finding. If you observe the sample spaces, you will clearly understand, because A is selecting in between your 1 to I minus 1 and B is selecting in between your again 1 to I minus 1, and we have to make sure that the cases of A have to be greater than B whatsoever, because the first digit is equal, right? Say first digit is 7 in both, then you have to make sure that the last two digits of A have to be greater than B. Only then the number will be greater, right? The number only then will be greater than B. So to make sure, to ensure this thing, you will find that exactly half of the total pairs give A's pair greater than B's pair. For exactly half of the total pairs, A's pair will be greater than B's pair. So basically the contribution for that, if you want to total, it will be I minus 1 C2 for selecting these pairs, and for selecting these pairs, and I minus 1 C2 minus 1. Why this minus 1? Because see, I might actually, if there was nothing for exclusion, then what would happen is it would have become I minus 1 C2 whole squared. Okay, I minus 1 C2 whole square. But because we have to exclude all those cases where this pair and this pair are having a tie. I hope you understand what tie means, where both of them are being equal. To exclude that, we have included a minus 1 in this particular bracket, because exactly half, right? So it is I minus 1 C2 whole square. I will expand this and write. It is actually I minus 1 C2 whole square, the total pairs, minus I minus 1 C2, and this is whole divided by 2. I minus 1 C2 whole square, the total number of pairs, minus the number of ties, that being divided by 2. Because why? Because exactly half of the total pairs will give A greater than B. That is what I have written here in a compacted form. This is for the second case. This second case is a bit complex. Okay. If you are facing difficulty understanding, nothing very difficult. You just have to study that and you will understand. Okay. So guys, I hope this was clear. So we have to once again sum this up. Like the last one we did, we have to again sum this up. This will be, I guess, wait, sigma So this will be from I equals to 4 to 9 once again, and this particular thing in the bracket. So if you sum this up once again, there will be a bit of calculation. So I am writing it down: 0 plus 3 plus 15 plus 45 plus 105 plus 210. This calculation will be much less than the previous one. So if you add this up, this will come out to be 378. Okay, so we now have the total number of cases. So basically total cases will be equal to 2730 from the previous one plus 378 from this case. So this will add up and come out to be 3108. Okay, so your probability of A being greater than B, not always, only greater than B, will come out to be 3108 by 4704 or whatever it was. So this will be a little bit of reduction. If you do that, it will come out to be 37 by 56, which makes option number C also correct. This was indeed, option number C was indeed the most difficult option in this entire question. Okay. And until, like, by the time you reach option number C not only is itself difficult, it will make you question option number A's correctness 100 times. When you in the exam hall, when you reach option number C, you will do option number C, and while doing, you will repeatedly look at the computer screen on your option number A, and you will keep on judging it that whether this is correct or not. Okay, that is the, like, this option number C is devilish type. Not only like, if you can't solve it, okay, but it will not take itself down on its own. Option number C will take itself down and also your option number A down. That is why this particular option is devilish. Anyways, so option number D says option number C in the same regard as 1 by 3. So this becomes wrong. Like, this is another mistake that most of you can do. You guys, maybe there will be a category of people who will consider option number A and option number C as exactly same, and then they will mark option number D as correct. So that goes wrong. There will be a second category of people who will switch option number A and option number C's answers. So basically they will get nothing. They will get only option number B, partial marking maybe. And there will be a third category of people who will not read option number A, will directly jump on to option number C and D. Like, they will have some sort of strategy that I will start doing from option number D and then I will go above, and they will go on to option number C and option number D. They will read option number D first and say, oh, this is correct, and they will mark it correct. They will say, oh no, option number C is wrong, then I will not do it, option number C is wrong, and they will get option number B as correct. So even though they did the entire hard work that I am doing right now on making this question correct, they will get a -1. They will not get a +1, +4. Why? Because they have, although found out option number B as correct, they have marked the wrong option. Okay. Like, that's the brutality of this question, guys. Really good question. Okay. These questions are expected in your JEE Advanced, and you should not make mistakes. If you have done your probability properly and you are making mistakes in this question, then I should say you need more practice. Anyways, so guys, that's the end for today's video. If you have liked my channel, do like, share and subscribe. Anything you want to say, you may come out in the comment section. Most welcome. And do join my Telegram discussion chat, because there we are having really good discussions for your JEE prep. So that's it for today, guys, and thanks for watching.